Hello, I'm Seema and welcome to part 5 of the chapter Alcohols, Phenols and Ethers. Moving on with our solution of problems of the textbook exercise regarding nomenclature of alcohols, phenols and ethers. In this video, I'll be doing question 11.2 and 11.3 of your textbook exercise. So let us start straight away. Now the names, IUPAC names have been given. In the previous video, what we did was we were given the structures and we were supposed to find out the names of those compounds. In this question, we have been given the names and the structures are to be made from the names. If you ask me, this is actually easier than the other type of question. And as I do it for you, you will understand why I feel it is so easy. Again, when we write down the names of compounds, the first thing in IUPAC nomenclature is to focus on finding the longest carbon chain. That gives us an idea of the parent hydrocarbon. And all other things kind of are attached to this parent hydrocarbon. So we do the same thing when we are making the structures from names, that we first find the parent hydrocarbon, we draw the skeletal structure, and then we can fill it up with the rest of the information that the name gives us. So write structures of compounds whose IUPAC names are as follows. There are 10 of these. I could adjust 7 on the board. I'll write down 3 later. The first compound is 2-methyl-butan-2-ol. 2-methyl-butan-2-ol. So which part of the name gives you the word root? You know, every IUPAC name has a word root where the word root is the longest chain or the parent hydrocarbon. So butan here is the word root. Then it has suffixes which give you the functional groups. It has prefixes which give you the substituents. Right? And then it tells you about saturation or unsaturation, which also comes in the suffixes. So it has primary prefix, it has secondary prefix, similarly it has primary suffix and secondary suffix. A name has 5 parts. If you do not understand what I am telling you right now, I would encourage you to go back to class 11's IUPAC nomenclature videos in which I have described this in details. So now we have to write the name of 2-methyl-butan-2-ol. Butan is my word root, which means that this compound consists of 4 carbons. So what will I do? I'll first write down 4 carbons and I'll leave a little distance between them so that I can fill up my hydrogens and the substituents. So the 4 carbons have been put in. Butane. Now since we are writing down the compound, sometimes it is easy to count the first carbon here as the first carbon because now we are writing the compound. So we have a choice which carbon to choose as the first carbon. So it is butan-2-ol. The second carbon should have an alcohol. So second carbon has an alcohol and the second carbon also has a methyl group. Right? It is 2-methyl-butan-2-ol. So 2-methyl-butan-2-ol. So this should be the basic skeleton of the compound. Now fill up the hydrogens to write down the complete formula. How do you fill up hydrogens? Terminal carbons, every carbon should make 4 bonds. So you count the number of bonds carbon is making and complete 4 bonds by adding the remaining number of hydrogens. For example, this carbon is forming only 1 bond. So it needs 3 hydrogens to complete 4 bonds. It means it is forming 1 bond with 1 carbon and 3 other bonds should be with the 3 hydrogens. This carbon is forming 2 bonds, so this should be H2. This carbon is forming 4 bonds already, so it does not need hydrogen. This carbon is forming only 1 bond, so this carbon also needs 3 hydrogens. So CH3, CH2, CH3. That fills up the hydrogens. All valencies are now satisfied and this is the structure of the compound. Second question. The compound is 1-phenyl-propan-2-ol. Word root, propan. Right? Because what has the functional group? That is the main compound. So propan 2 all. Propane means 3 carbons. So 1, 2, 3. It is propane 2 all. Second carbon has alcohol on it. And the first carbon has phenyl group attached to it, which means you can put a benzene ring here, which will show phenyl group. Or if you do not want to make the benzene ring, you could simply write C6H5. C6H5 also could be written, right? So C6H5, C, it is propane 2 all. That's not a double bond, it's a single line. It was lighter, so I was trying to darken it, right? So now fill up the hydrogens. This carbon is forming only 1 bond, it needs 3 more. This is forming 3 bonds, it needs 1 more. This is forming 2 bonds, it needs 2 more. And phenyl is already completed. So this is the structure of the second compound. 1 phenyl, the phenyl is on the first carbon, the all is on the second carbon. Next compound, 3,5-dimethyl hexane 1,3,5 triol. Where is the word root? Which compound, which part has the alcohols? The hexane has the alcohols. So hexane is my word root. Hex means 6 carbons. So I'll make a chain of 6 carbons. 1, 2, 3, 4, 5 and 6 carbons. 3, 5, I'm counting from this direction. This is carbon 1. 1, 2, 3, third carbon and the fifth carbon. What do they have? Methyl groups, CH3, CH3. So it makes it 3,5-dimethyl 1,3,5 triol. 1, this has OH, 3 has OH and 5 has OH. 1,3,5 triol. 3,5-dimethyl 1,3,5 triol. And the compound is hexane. 1, 2, 3, 4, 5, 6 carbons. So this is my skeleton. Fill up the hydrogens now. This carbon is forming 2 bonds, so it needs 2 more hydrogens. 2 bonds, 2 more hydrogens. 4 bonds, no hydrogen. 2 bonds, 2 hydrogens. 4 bonds, no hydrogen. 1 bond, 3 hydrogens. So that completes your compound. Come to 4. 2,3-diethyl phenol. So phenol is the parent. Make the phenol first. 1, 2, 3, 4, 5, 6. Benzene ring and OH, which is the first carbon. This is phenol, parent hydrocarbon, you've made it. 2,3-diethyl. So if this is OH, let us start counting from this direction. This is 2, this is 3. And both are ethyl groups, which means C2H5, C2H5. Here, since it's the benzene ring and we only draw the structure, there is no need of writing down each and every hydrogen. So this is 2,3-diethyl phenol. Next, part 5. 1-ethoxypropane. Propane is my parent. So 1, 2, 3. 1-ethoxy. 1, this is the first carbon. It has oxygen and it has ethoxy, which means ethyl group, which is C2H5, which can also be written as CH2, CH3. Right? Ethoxy. So 1, this is the first carbon. 1-ethoxy, this is the substituent. 1-ethoxypropane. So this carbon is forming 2 bonds. It needs 2 hydrogens. 2 bonds, 2 hydrogens, 1 bond, 3 hydrogens. So this is 1-ethoxypropane. 2-ethoxy 3-methylpentane. Now pentane is the parent. So make 5 carbons. 1, 2, 3, 4 and 5. Now 2-ethoxy. Second carbon has ethoxy on it. So I can write OCH3. Oh, sorry, C2H5. Either I can write it like this or I can just, instead of making this look like a huge branch, I can make this, I can turn the chain in this direction and put the OC2H5 here, just to make it look more symmetrical. It makes no difference, you know. This chain is going down like this. If I assume that this chain is turning here to give me this carbon here, and I put the ethoxy here, which means O, CH2, CH3. This is ethoxy, and I put the carbon here. This is pentane. So this is 2. On the second carbon, you have ethoxy. On the third carbon, this is the first carbon, second, this was the first carbon which was here. I have only shifted its position downwards so that it becomes easy for me to write. Instead of writing such a big thing down here as a branch, it is still a branch, but I have made it appear to be, made it on the side. So the third, this is carbon 1, carbon 2, carbon 3. Third carbon has a methyl group attached to it, CH3. And it is pentane. Fill up the hydrogens. This carbon forms only one bond, so it has CH3. This carbon is forming 3 bonds. It needs only 1 hydrogen. 3 bonds needs only 1 hydrogen. 2 bonds needs 2 hydrogens. 1 bond needs 3 hydrogens. So ultimately, with the hydrogens, you fill up all the bonds to make carbon having 4 bonds to satisfy the tetravalency of carbon. 7th, cyclohexyl methanol. Cyclohexyl methanol. Methanol is CH3OH, but CH4 is methane, right? CH4 is methane, but to CH4 the all has been attached, so CH3OH would be methanol, but one of the hydrogens has cyclohexyl, so CH3, instead of CH3, now you have CH2, and what is attached to it? Cyclohexyl. This is cyclohexane. So cyclohexyl methanol. Methane has only 1 carbon, so there is no need of locants. This is methanol, CH2OH, cyclohexyl methanol. Now, let us write the next 3 compounds. The next 3 compounds are, we've done it till 7, so 8 is 8. Compound 8 is 3-cyclohexyl pentane 3-ol. Okay. 9th is cyclopent 3N1-ol, and the 10th is 3-chloro-methyl pentane 1-ol. Okay. So let us now write down the structures of these 3. The first is 3-cyclo, or the 8th compound is 3-cyclohexyl pentane 3-ol. Pentane 3-ol. So parent is pentane, 5 carbons. So 1, 2, 3, 4, 5 carbons. To the third carbon, OH is attached. And to the third carbon, cyclohexane has been attached. So this is cyclohexane, and the OH is also attached to the third carbon, and this is 3-cyclopentane 3-ol. Fill up the hydrogens. Again, cyclohexane, there is no need of writing they are all CH2, CH2, CH2. They are all, CH2, 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 CH2. And since we draw only the structure for the cyclic compounds, there is no need of writing that. But here we need to fill up the hydrogens. 1 bond, 3 hydrogens. 2 bonds, 2 hydrogens. 4 bonds, no hydrogen. 2 bonds, 2 hydrogens. 1 bond, 3 hydrogens, and that is our compound. Now comes cyclopent 3N1-ol. Cyclopent, pent, 3N1-ol. So it is cyclopent. It is a cyclic but 5 carbons. So instead of making, we can slant this slightly towards the inside. This is cyclopentane. Okay, so cyclopent, this is cyclopent. Let us say this is 1, so this is OH here. Pentane, cyclopent 3N. If this is carbon 1, this is carbon 2, this is carbon 3, and the third carbon is unsaturated, which means it has a double bond. So it is cyclopent 3N1-ol. This will be the structure of the compound. Then 3-chloromethylpentane-1-ol, last one. 3-chloromethylpentane-1-ol. So pentane again 5 carbons. 1, 2, 3, 4 and 5. 3-chloromethyl. This is the third carbon counting from this direction. 3-chloromethyl. So chloromethyl will be CH2Cl. Methyl group having a chlorine substituent further. So substituent further has a substituent. This is a chloromethyl substituent. And pentane 1-ol, the OH is here. So this has 2 carbons, 2 bonds, therefore 2 hydrogens, 2 bonds, 2 hydrogens, 3 bonds, 1 hydrogen, 2 bonds, 2 hydrogens, 1 bond, 3 hydrogens. And that is our compound. Right? Now we'll be doing the next question, which is 11.3. Give me a moment, let me write down the question. Alright, so this is question 11.3. You have to draw the structures of all isomeric alcohols of molecular formula C5H12O and give their IUPAC names. The second part of the question is that classify all of them as primary, secondary or tertiary alcohols. It's very interesting. Let us start in the same way. We have been given a general formula and we have to write all the isomers, alcoholic isomers of all the alcohols that can be made from this general formula. So let us write down the first C5. It means it has 5 carbons. So the first compound that I would make would be 1 containing 1, 2. I'll write the skeletons first. 3, 4, 5. There are 5 carbons and there should be an OH. Alright, so this is my first compound. So let us write down, fill up the hydrogens, CH3, CH2, H2, H2, the same thing, you know. Whenever there are 2 bonds, you'll add 2 more hydrogens to make it 4. If there is only 1 bond, you'll add 3 hydrogens to make it 4, and so on. So this is your first compound. Now what will I do? We'll do the naming later. Let us draw as many structures as we can first. So the first thing let us do is shift the alcohol. Let us keep the carbon chain straight and see how many shifting of alcohol can we do. So this is the first one. The second one would be, let us shift alcohol from carbon 1 to carbon 2. So C1, 2, 3, 4, 5. The alcohol is here. Third compound, 1, 2, 3, 4, 5. And the alcohol is on the third carbon. If I put alcohol here, then the counting begins here and it becomes the second position. So we cannot have any more structures where we can have the straight chain of 5 carbons and move the alcohols. So our next compound, 4, would be, let us now assume that the alcohol goes back to the first carbon and one of the methyl groups makes a branch instead. Instead of alcohol moving as a branch, let us take a methyl group. So if we take the methyl group, now we have butanol. So 1, 2, 3, 4 carbons with OH here, but 1 methyl group comes here, right? Fifth compound, the methyl group could be here also. So 1, 2, 3, 4 OH and the methyl group is here, right? This is my next compound, 6. Now we will assume that both OH and CH3, they are both coming on butane. They are on the central atoms. So one branch remains. We write 1, 2, 3, 4. CH3 is here and OH is here, right? Now the 7th compound could be 1, 2, 3, 4. The CH3 is here and the OH is also here, right? One more variation we can make now where there are 2 methyl groups, right? So if instead of OH it was 2 methyl groups, 2 branches, then we could have 1, 2, 3 carbons, OH, and 1 methyl group here and 1 methyl group here. So which makes 5, 1, 2, 3, 4, 5 carbons and OH. 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 That is what you have to do. These are the maximum number of structures that I can make which have OH in them, which means that they are alcoholic. Let us now name them. This, what would be the name of this compound be? Word root 1, 2, 3, 4, 5, it is pentane 1 all. The alcoholic group is on the first carbon. Now, which is a primary alcohol? A primary alcohol is one in which the alcoholic group is attached to a carbon which is attached to only one other carbon. Secondary alcohol 2 degree will be where the alcoholic group is attached to a carbon which is attached to 2 other carbons. And tertiary would be where alcoholic group is attached to a carbon which is further attached to 3 other carbons. So this is a primary alcohol. You can see here, it's a primary alcohol. Let's name this and complete the structure also. This becomes CH3, CH2, H2. This will become only H because it already has 3 and 3. How would you name this? This is pentane 2 all. We are counting from this direction. The OH is on the second carbon, so it is pentane 2 all. And here OH is attached to a carbon which is attached to 2 other carbon atoms, which means it is a secondary alcohol, 2 degree. Here again fill it up, H3, H2, H, H2, H3. And this is again pentane 1, 2, 3, 3 all. And this is also secondary. Why? Because the OH is attached to a carbon which is further attached to 2 other carbon atoms. Name this now. Let us first fill up the structure. H3, H, H2, H2. Okay? Now, this is butane. The parent hydrocarbon is here. So, it is butane 1 all, and the methyl group is attached on the 1, 2, 3. 3 methyl, and since it is butane 1 all and the name is not starting with B, this B should be a small alphabet and there should be no gap. So the name is 3 methyl butane 1 all, and the OH is attached to a carbon which is attached to only one other carbon, so it's a primary alcohol. Name this now H3, H2, H, H2. This is also butanol, right? But the methyl is attached to 1, 2. All is on the first carbon, so methyl is on the second carbon. So it is 2 methyl butane 1 all. And this is also primary. Fill up the hydrogens. 3 hydrogens, 1 hydrogen, 2 hydrogens, 3 hydrogens. This is already having the hydrogens because we wrote methyl group. So this is also butane. So it is butane 2 all. we'll say all is on the second carbon, we'll count from this direction. 1, 2, 3, 4. So it is 3-methyl butane 2-ol, right? But this OH is attached to a secondary carbon. You see, this carbon is attached to two other carbon atoms. Therefore, this is a secondary alcohol. Seventh one. 1, 2, 3, 4. Fill up hydrogens. H3, C, H2. No need of hydrogens. It is already forming 4 bonds and H3. So this is also butanol. So we'll start counting from this direction because the locant here we get is 2, 2. But if we count from this direction, locant is 3, 3. So we'll count from this direction. It is 2-methyl butane, there's no hyphen, butane, now hyphen, 2-ol. Okay, 2-methyl butane 2-ol, and here it is, this OH is attached to a carbon which is attached to 3 other carbons, therefore this is a tertiary alcohol. Fill up here, H3, no need of any hydrogen, H2, and these two are already H3s. So what is the name? This is propanol. So it is propanol, this is the first carbon, so it is propane 1-ol, and this is the second carbon, so 2, 2, it will be 2, 2, dimethyl propane 1-ol. Okay, and OH is attached to a carbon which is attached to only one carbon, therefore this is a primary alcohol. Although it appears to be a tertiary compound, the alcohol is primary. Right? So these were the different compounds. Now, one more thing. This question has a little trick in it. The same question can be made slightly more difficult by the examiner when he says that this is the formula and write as many isomers as you can from it. He does not mention the alcoholic isomers. Then, do you know that with the same formula, you could write ethers too? How could you write ethers? There are 5 carbon atoms. Just imagine that this is the OH. If I have 5 carbons, let me just make one and show it to you. 1 carbon on this side, 1 carbon on this side, 2 carbons on one side, oxygen here, 1, 1, 1. Okay? So, fill up the hydrogens, H3, H2, 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 H3, right? 3 plus 3, 6, 7, 8, 9, 10, 11, 12. So C5H12O gives you an ether. And what is this? This is ethoxypropane. You would have named it as ethoxypropane. And from this, you could have made other ethers also where they would be, where they could be like 1 carbon on one side and 4 carbons on the other side, and you could be getting more isomers, but then they would not be alcoholic and you would not be talking about the primary, secondary and tertiary. They wouldn't all be alcoholic. So this was a little twist in the question that you could experience during the exam, so read the question carefully. So with this we come to the end of nomenclature of alcohols, phenols and ethers. And now we will be moving on to the next topic in the next video. So let me wind up this video here. If you wish to watch other videos of this chapter, click the link that appears on top of your video. If you found this video helpful, give it a thumbs up. Subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching. Bye-bye for now.